When the stimulus is a sound, the neural process is as follows. Sound waves move the tympanic membrane, or eardrum in the middle ear. The tympanic membrane moves the ossicles, a series of small bones. Ossicles move the membrane at the oval window. Motion at the oval window moves fluid in the cochlea in the inner ear. Movement of fluid in the cochlea causes a response in sensory neurons. Once a neural response to sound is generated in the inner ear, the signal, after activating the spiral ganglion and then via the auditory vestibular nerve, is transferred to and processed by a series of nuclei in the brainstem, including the dorsal cochlear nucleus and ventral cochlear nucleus of the medulla. Axons from the ventral cochlear nucleus project to the superior olivary nucleus on both sides of the brainstem. Axons of the olivary neurons form the lateral lemniscus and innervate the inferior colliculus of the midbrain. The auditory process is more complex than the visual one, with many parallel auditory pathways. However, all ascending auditory pathways converge onto the inferior colliculus. Output from the inferior colliculus is sent to the medial geniculate nucleus of the thalamus. Once again, at this point, the thalamus doesn't know yet if the signal it is receiving has any association with danger or not. However, since it is possible that there is a danger, there might be a burglar in the house, the thalamus forwards the information to the amygdala, the low road, just in case. On receiving this signal from the thalamus, amygdala sends neuronal impulse to the hypothalamus to initiate the fight or flight response that could save your life if what you are seeing and hearing turns out to be an intruder. On the other hand, the medial geniculate nucleus projects the signal to primary auditory cortex in the temporal lobe, the high road. Further, the sensory cortex determines whether there is more than one possible interpretation of the received information and passes it along to the hippocampus to establish context, the high road. The hippocampus compares new data to the previously stored memories and asks questions like, have I seen this particular stimulus before? If so, what did it previously mean? What else could help me to identify whether this is a burglar or a cat? The hippocampus might pick up on other background information being relayed through the high road, like the cat's meowing, a sound of the small animal's footsteps, and the absence of unfamiliar human voices. Taking into account this additional data, the hippocampus determines that the noise is most likely created by the cat. It sends its message to the amygdala that there is no danger. And the amygdala in turn tells the hypothalamus to terminate the fight or flight response. Furthermore, information from all the sensory systems goes into the amygdala, particularly the basolateral nuclei, and interconnections within the amygdala allow the integration of information from different sensory systems. From the basolateral nuclei of the amygdala, the signal is relayed to the central nucleus of the amygdala. From the central nucleus of the amygdala, the signal goes to the hypothalamus, resulting in the autonomic response, and to periaqueductal gray matter in the brainstem, causing the behavioral reaction to the stimulus. From the basolateral nuclei of the amygdala, the signal also proceeds to the cerebral cortex, where the process of the emotional experience occurs. It is important to notice that the sensory information regarding the stimuli follows both the high and the low road at the same time. However, it takes longer for the signal to travel through the high road compared to the low road. This is why when the sensory data does not come from an actual source of danger, one will experience a moment or two of terror before calming down, while one's brain processes information using the high road. Another valuable observation is that all roads lead to the hypothalamus. This area of the brain is capable of calling the fight or flight response that might save your life. In the next video, we will talk in more details about the fight or flight response.